Welcome to the Unit 7.3 Synopsis video. This video gives a brief summary of MyStar's Unit 7.3, Cooling Hot Dogs, Moving Thermal Energy. Unit 7.3 is one of 4 7th grade units that focus on energy and matter and addresses several NGSS concepts that relate directly to the engineering process. The unit takes approximately 26 50-minute class periods to complete. The unit is built around the unit challenge question, how can scientific principles be used to design, construct, and test a device to keep a dog crate from overheating during hot days? The hot dogs in the full title does not refer to a food product, but to the animal so many people keep as pets. In the unit challenge scenario, the local Humane Society director is seeking proposals to address temporary overcrowding in the shelters. In response to several national natural disasters, the Humane Society had an influx of dogs, as other shelters have closed or had to displace animals for their safety. The director is looking to be proactive and prepare temporary outdoor shelters that can house the overflow on hot days. A group of area citizens is determined to develop a better solution for the future. Their plan involves placing extra dogs in individual crates outside of the main building. Since the shelter is most concerned about the heat, the dogs must be kept cool. To address the unit challenge, students dive into the engineering process. The phrases in gold highlight the science and engineering practices the students experience as they progress through the unit. You may wish to pause the video here to read through these 2 performance expectations. And here's the 3rd and last performance expectation for Unit 7.3. The key science concepts in this unit are the difference between thermal energy and temperature, and how energy flows through a system. Molecules are constantly and randomly moving and colliding with one another. This means that molecules have kinetic energy, just like a moving billiard ball. The amount of kinetic energy carried by the molecules depends on the mass of the molecules and how fast they are moving. The sum of all the molecular kinetic energy in a system is referred to as thermal energy. The average kinetic energy of the molecules in a system is the temperature. When 2 substances are in contact, their molecules collide. All of those collisions result in a transfer of energy between molecules. When 2 substances are the same temperature, small amounts of energy are traded back and forth, but the amount of energy transferred in each direction is the same. When 2 substances have different temperatures and random molecular collisions happen, the molecules with more kinetic energy tend to slow down, and the molecules with less kinetic energy speed up. Through random collisions with other molecules, these energy transfers that occur in each individual collision result in an overall movement of thermal energy, from areas of higher temperature to areas of lower temperature. The molecular movement is random, but the overall transfer of kinetic energy is predictable. Remember, if you need to refresh your understanding of the science concepts in this unit, check out the Teacher Background Content resources circled here in green, which you can find online in the Curriculum portal under the Unit Content Resources. Now that you have a big picture view of Unit 7.3, we'll take a quick look at the 7 lessons within this unit. Each lesson helps students to attain the necessary content to create their prototype. We begin by looking at what students already know and can relate to. How does it feel to be in a car without air conditioning on a hot day? What do we do to combat the heat? Students become familiar with the unit challenge by empathizing with the living conditions of these dogs on hot days. In Lesson 2, students investigate the effects that temperature has on molecular motion as food coloring is added to water. Next, students discover that energy always transfers from areas of higher temperatures to areas of lower temperatures as they observe digital simulations and explore a physical model of how hot cocoa cools over time. For Lesson 4, students conduct a hands-on investigation of factors affecting temperature change. such as mass and type of material, as they add heated bolts to water and oil. In Lesson 5, students track the flow of energy through a cooling can model and use this information to create an initial prototype and a plan for testing for their dog crate. Note that students will use plastic food containers, like these, to represent dog crates in testing. At the beginning of Lesson 6, students practice optimizing a solution by testing which factors most influence the rate of temperature change when using psychrometers. Students transfer what they learned in the psychrometers experience to their prototype crates by modifying, retesting, and tracking the results of their various iterations. Students gather their unit work and present the results of their unit challenge projects. This includes an email to the Humane Society director which explains how their design addresses the problem, how their design performed during testing, the scientific concepts that make their design work, and the limitations of their model. Teams may also provide any other student-created material. Although Unit 7.3 has several tricky concepts that are both content and application-focused, this unit is also an incredibly engaging one for students due to the many modeling and hands-on activities. Students quickly become invested in their dog crate prototypes, which motivates them to apply the understanding and skills they learn in each lesson. We hope you enjoy Unit 7.3 in your classroom.